Imagine I have a car in Augsburg that travels at 100 kilometers per hour on average, and I want to go to Paris, which is 700 kilometers away. Now, without doing any math, physics, or anything, I want you to, in your head, tell me how long it will take me. Pause the video, say the answer out loud. Okay, now hopefully all of you figured out that it will take me 7 hours to go to Paris without doing any physics. Why? Well, because it's common sense, right? Why would you learn mathematics or any physical techniques to solve something like this? That seems pretty silly. However, that's exactly what we're going to do. I'm going to teach you a technique to translate all this information into mathematics that then you can use to solve any problem. And the reason for this is that, yes, this is a very easy problem, but most problems you actually encounter in real life aren't like this at all. So for example, you may have heard that Napoleon conquered most of Europe in a matter of years. And the way he did it was by using something that I'm sure you all are familiar with, just cannons, right? So he had this cannon, and then there were these people in this fortress, and they were like, we're in a fortress, you can't reach us. Because they thought that they would be attacked with, horses and archers. However, with a cannon, you can, pretty much go over the walls and into the city, and the walls are pretty useless. So thanks to the cannons, Napoleon won a lot of wars. Now, guess how Napoleon knew how to place these cannons so that the ball would go in the city and not, here or past or anywhere else? Well, for this you need physics. And you can't do this with common sense anymore. You need to have a very, very clear idea of what you're doing. However, if you want to know how to do this, you first need to learn how to do what I just told you to do. You start with a very, very simple case, which you could probably do with common sense, but you just do this to develop the mathematical formalism. Now, once you have the mathematical formalism, then you can apply it to very complex situations like the cannon and solve things that you could never, ever possibly solve using common sense. So bear with me for a while. I know it's going to be a little too easy at the beginning for some of you, and you will be like, but why are we doing this? I can do this with my head already. Well, yes, but it's only after we develop all this mathematical formalism that we will be able to tackle much, much, much harder problems that you could not possibly tackle using only your common sense. So let me give you an example. And I can assure you that by the end of this video, we will all know how to solve this problem. Now, I have two bikes. Yes, this is a bike. I don't know what it looks like, but it's supposed to be a bike. It took me 2 hours of work. That are placed at 0 kilometers and 70 kilometers. And then they start to move towards each other. So this one moves this way, this one moves this way. And this one moves this way at 15 kilometers per hour, and this one moves this way at 20 kilometers per hour. At the same time, there is a fly that moves this way at 30 kilometers per hour. And then when it runs into the next cyclist, it starts moving back until it runs into this guy, and then keeps doing this until it stops at one spot. And what I want you to figure out is two things. First thing, where is this fly going to end up? And second thing, how much distance will it have covered by the time it reaches this point? Now, unless you are extremely confident, don't even try this. All I want you to see is that this is really, really hard to do with common sense. But thanks to the mathematics that we're going to develop in the next slides, by the end of this video, we will be able to solve this extremely complex problem. Now, in physics, every time that we want to solve a really complex problem, we do something that's admittedly a little dirty, but that's how we roll. What we do is just like, forget about that problem. I'm just going to solve something easier. Yeah, I know it's not great, but that's how we do things. So in this case, it's like, okay, well, how about we forget about this bike, we forget about the fly, then have this guy here, running at 15 kilometers per hour, and it's going over here. And I want to know how long it's going to take to arrive here. Now, this is not very complicated. Well, first thing, I need to look at the distance, right, between here and here. And this is obviously 75 kilometers, which is 75 minus 0. if this had been 2, so if this thing had been 2 kilometers, then the distance would have been 73, right? So we take this point, we subtract this point, and we have the distance. Now, I know this seems pretty silly. Yeah, everybody knows what distance is, but in physics, we need to give it a very precise meaning. And in this case, distance is just, well, the length between these 2 points. And you'll see that things are not as easy as they seem in a while. So anyway, we know the distance, and we know that this guy does 15 kilometers every hour. Now, everybody knows how we call this thing, right? We call this the speed. So the speed of this guy, and we're going to write it with the letter S. So this is the distance d, and then the speed S is 15 kilometers per hour. And now, even though I haven't defined these things, these are 2 new physical concepts, distance and speed. And what do they mean? Well, what everybody knows they mean. Speed is just the distance that I do every hour or every second if you're doing it in seconds, so every unit of time, and the distance is just the length between 2 points, right? Okay, so I have the distance and I have the speed, and I want to know how long it's going to take this guy to reach 75 kilometers. Now, if you can do this with your head, go ahead, pass the video forward. If you can't, here's how I figure this out. So I have this bike, and after 1 hour, it's going to do 15 kilometers. And then after another hour, it's going to be 30, then 45, then 60, then 75. And then I'm here. So let's count these things. So 1, 2, 3, 4, 5. So it took this guy 5 hours to reach this. Another way that I could say this is, well, I need to divide this 75 kilometers in 15 kilometer chunks, right? So I divide this by this. Now, I can say this, or I can write this down as a mathematical formula, right? So the time that it took me is going to be the distance, in this case 75 kilometers, but since I want this to be useful for any distance, not just this one, I'm just going to write d. So okay, so here's my distance divided by my speed, right? So distance over speed. That's the time that it's going to take me to do this. And if I know anything about math, I know that I can translate this to be something like this. So distance equals speed times time. And these 2 things are the same thing. All I did was multiply this by speed, multiply this by speed, so that I get this formula. If you have difficulty doing this kind of transformation, please come to see me, because this is extremely important. That's why we were doing this in grade 6, grade 7, and grade 8. So come to see me and we'll figure something out. All right, so we figured one easy problem out. Now let's look at this problem, which is the same, but backwards. Now, of course, I can ask myself, how long is it going to take this thing to reach here? And the answer is going to be, again, 5 hours, because it's the same distance and it's the same speed. But this is not the same problem, is it? Because before there was a guy that was moving from here to here, and now there's a guy that's moving from here to here. It's not the same thing. So we should have some way of telling ourselves that this is not the same thing, because when we have the 2 bikes, so when I add this other bike here, if we use the same numbers for both, we're going to end up very confused, because this one's moving this way and this one's moving this way, and we need some way to tell these 2 apart. Now it turns out that the concepts of speed and distance are not enough to tell us the difference between those things, which means that we need to make new ones. But thankfully, it's pretty easy. Okay, so let's get started. Now the first thing that I ask myself is, well, okay, again, the distance between here and here is 75 kilometers. However, when I move, I'm not moving from here to here, so 75 minus 0. I'm moving from here to here, right? So I start at 75 and I end up with less kilometers. Now, intuitively, what I think is, well, if I want to, so I'm moving backwards, right? So if I want to express the fact that I actually move backwards, what could I possibly use mathematically? Okay, so I have 75 kilometers, and I want to add something to this so that people know that, yeah, it's 75 kilometers, but backwards. Okay, pause the video and think, how could you possibly express this mathematically? Now, hopefully you listened to me, you paused the video, and you came up with this answer. If I add a negative sign here, everyone can understand that I moved 75 kilometers backwards. Just like forward is plus 75, then backwards is minus 75. Now, but this is not the distance anymore, right? Because the distance between here and here, no matter how I look at it, that's always 75 kilometers. So I can't call this thing a distance, because distance can't be negative. That makes no sense. So I give it a new name. I'm going to call this thing displacement. And the only difference between this distance and displacement is that displacement can be negative. So displacement going from here to here is still 75, but if I go from here to here, that's minus 75. Displacement is like an extended distance, something that allows me to know not only how much I moved, but in which direction. And that's very interesting in general, because, it's not the same if I move this way than this way. It's not the same if I'm going up a mountain than falling off a mountain, and so on. So normally we use displacement, we don't use distance. Now we're going to need a different concept, and it's the same thing, right? So here we have the speed, and again, this speed is backwards, right? This guy is not moving forward, it's moving this way. So we have to have another way of expressing this. And again, so I write myself, okay, so I have 15 kilometers per hour. How could I possibly modify this to express that this is going backwards? And I hope you can deduce this. All I need to do is add a little negative sign, right? This means 15 kilometers per hour this way. Now, again, I can't call this speed because I can't have a negative speed. That makes no sense, right? I'm either still or moving at some speed. Negative speed is a little weird. So I need to call this something else. And I'm going to call this velocity. And again, this is just like displacement. So displacement is like distance, but with a minus. Velocity is just like speed, but with a minus or without a minus. So if I'm going this way, then velocity is just like speed. If I'm going this way, then velocity is like speed with a minus sign. Velocity can be negative, speed can't be negative, displacement can be negative, distance can't be negative. Now I'm going to take the equations that I developed before and I'm going to apply them to this situation using the new concepts that I just made up. Now remember that we decided before that that distance is speed times time. Now, in this case, instead of distance, I'm going to use displacement. So I'm just going to write displacement. And then instead of speed, I have velocity. And that's it. So these two things work. Both of them work almost all the time. All I need to take into account is that if I'm using displacement, which can be negative, then I need to be using velocity and not the speed. But things are never that simple. So imagine I have this little ball, and I'm going to move it from 0 to 75 kilometers. Now, until now, we've been assuming that this is what happens, right? This moves always at the same speed. But what if I told you that actually things don't always move at the same speed? So, for example, the ball could be doing this. Or it could be doing this. Whoa. Until it reaches here. So that's a problem, right? Because what's the speed of this thing? Well, it depends, right? Now at the beginning it's really slow, then it gets faster and faster. Now, how on earth do I represent the fact that this is moving around? So now it's forward, now it's backward, now it's forward, now it's backward, finally gets here. This is a nightmare. It's really, really hard to represent this movement mathematically. So we need to do something about this because, otherwise we're going to go nuts. So what we do is say, well, okay, the distance, I still know the distance, right? Yes, I do. It's from 0 to 75. I don't care. This thing did this, did whatever, but it still went from 0 to 75 kilometers. So I still know the distance. Oops, sorry. So I know the distance, which is 75 kilometers. Good. And I still know the time that it took. Okay, so yeah, okay, I'm moving this thing around. like this, but I can count that it took, let's say, 2 hours to get here. So I also know the time. So I know the distance and the time. And remember that before we had that speed was really the distance over the time. Okay, well, now this is not true anymore because my speed is changing all the time, right? So I start very slow, then I got faster, then I go backwards, so I do all kinds of stuff in between the beginning and the start. However, I can solve all my problems if I do this. There you go. So see, now I don't care. Okay, I don't know the speed at each point, but I know the average speed, which is just the distance over the time. I don't care what happens in the middle. So you can do whatever you want as long as I know the time. Whoops, sorry. As long as I know the time and I know the distance, then I know the average speed. What I don't know is the instantaneous speed, the speed at each separate moment. And sometimes I will know this, sometimes I won't. But as long as I know the distance and the time, I will know the average speed. And the same thing happens with the velocity, right? So if I know the displacement and I know the time, I also know the average velocity. So here's my average velocity. Is just the displacement over the time. Easy, piece of cake. So the beauty of this is that I can simplify movement a lot. I really don't care what happens in between as long as I know the averages or as I know the distance and the time. If I don't know 3 of these, then yeah, well, then I have a problem. But most of the time, because physics teachers are not evil, you will know at least 2 of these 3 things, and then you can figure the rest of them out. Now comes the part that everybody loves, units. Now, we've been doing things in kilometers per hour. And the reason we've been doing this is that, your cars work in kilometers per hour. Everybody's used to kilometers per hour. And when we think about speed, we think about kilometers per hour. However, in physics, we don't use these units because we use the international system units. And hopefully you remember which ones they are. Now, let's just quickly recapitulate. We know that the international system unit of distance is, please say meter. I really hope that you remember that it's the meter. If you don't, please review it. It's the meter. Distance is measured in meters. Okay. Now, which one is the unit of time? Now, hopefully you will remember that it's not the hour, it's the second. So, speed is not measured in kilometers per hour. We actually need to replace each one of these with its SI unit. So, take 2 seconds, pause the video, and say out loud, what are the SI units of speed or velocity? Well, hopefully you know that instead of kilometers, you need to use meters, and instead of hours, we need to use seconds. So the international system unit of speed or velocity is the meter per second. Yay. Now that that's out of the way, let's move on. All right, now a quick summary before we start doing problems. First thing, displacement. Now remember, displacement is just how much I moved and in which direction. So if it's forward, it's positive. If it's backwards, then it's negative. Normally, if I know my initial position and my final position, I can calculate the displacement just by subtracting this one from this one. So, for example, let's just say that this is my initial position, and let's just call this xi for initial. And this is my final position. Let's just call this xf. So if I want to calculate the displacement, I just subtract my final position minus my initial position. If it turns out that my final position is smaller than my initial position, so for example that's 70, that's 0, then I will get a negative displacement. Now distance is just like displacement, but we don't care about the sign. We don't care whether we're moving backwards or forwards. So distance is just like displacement, but cannot be negative. So like displacement, but always positive. Now velocity is related to displacement. It basically tells us how much I moved every second. Now, just like displacement, if I'm moving forward, it's positive. If I'm moving backwards, it's negative. Now, how can I calculate velocity? Well, easily enough. Velocity is just the displacement per unit time. So I just take the displacement and I divide it by the time. Now, my speed is just like my velocity, but it cannot be negative. So if I'm moving forward, then it's positive. If I'm moving backwards, it's still positive. So speed is just like velocity, but positive all the time. Whereas velocity depends. Now, finally, there's one formula that we need to calculate stuff, and it's just that the displacement is equal to the average velocity times the time. And this is key, guys, because you will find a lot of times when there's something that's moving and its velocity is changing all the time, and people are like, oh, displacement is velocity times time, so I take this velocity and I multiply by the time, and that's the displacement. Well, no. This has to be the average. So if I start out very slow and I end up very fast, then I need to take the average between my slowest velocity and my fastest velocity, and then I multiply it by the time. This is a classic mistake. Make sure that you always know the average velocity, not just some random velocity in between. Now, consider this a red-black problem, which means that if you think you got this and you think that this looks way too complicated for you, feel free to skip and do the quizzes that are just after the video. However, if your curiosity has been piked, I don't know how it's called, stay around and I will solve this problem for you using what we learned, okay? So here we have two bikes, bike number 1, bike number 2. So what we need to do in order to figure out how much distance this flight is going to run is, first thing, write down equations for all of our stuff. Now, for the bikes, it's really easy, so let's start with the bikes. Now, for the first bike, we have that the distance is going to be 15 kilometers per hour times the time. Now, in this case, I'm not going to use the displacement but the position. That is, the position of this bike is now 70, and then its position will be always 70 minus the displacement, right? So if once the displacement is minus 1, then this guy is going to be at 69 kilometers, then it's going to be at 68, and so on and so on and so on. So basically its position will be its distance, well, this distance minus its displacement. Okay, so let's write that down. So this position, let's call it D2, so is going to be 70, which is its initial position, minus, because it's moving backwards, 20t. And what happens is that when these two bikes meet, this position has to be the same one, so that this has to be equal to this. Okay, so now we have a system of equations which you should hopefully be able to solve. But so I encourage you to do this yourself, but if you can't, I will do this for you. So I have 15t equals 17 minus 20t. Then all I need to do is put this thing over here, adding up. So then we have 35t equals 70, and then t equals 2 hours. And now, here's the beauty of this method. Now, we know these guys are going to meet at some point here after 2 hours. We don't even care where. And we want to know the distance that this guy went. Well, yes, we could figure out how long it goes until it meets this one, then this one, then this one, then this one, then this one. This would take us ages. And it's a very, very, very silly way to do things. Because we know that these three guys will meet at the same point, right? This one will go until the three of them are in the same point. So therefore, this will happen after 2 hours. Now, let's use the equations that we learned before. Now we know that the distance is the speed times the time. Okay, so what's the speed of the fly? Well, 30 kilometers per hour. What's the time? 2 hours. Okay, so the distance that the flight went through is 30 times 2 equals 60 kilometers. That easy. But we wouldn't have been able to do this without our mathematical formalism. So I hope that you understand the reason behind all this. Even though it looks very, very easy for simple problems, it is extremely useful when things get a little complicated like this. All right, well, that was it for the moment. Now I encourage you to try the quizzes and quick questions that are after this video, and the reason why I want you to do this is that one thing is listening to me and another one is learning and having and remembering everything that you learned during this video. The second reason is that actually being asked about things just after you learn them helps to keep things in your head. And this will be very, very helpful because there's lots of stuff in the IGCSE and you're going to need to remember a lot of it. And the sooner we get these things in your head so they're stuck there and they can't leave, the better. So try these out. This way I will know who is struggling with this stuff, and then when the day comes for class I can help you individually. Good luck.